When you do interaction design, there is this idea that you need to be able to build prototypes, because one of the, in a way, important elements of that discipline is being able to test the things you do with people. So, you want to make a website, you make a prototype, a mock-up of the website, you try it with people, you see how they react. And the same thing with physical devices. But physical means that you need to learn about electronics. So we had to create different classes that would basically make electronics approachable to people that don't have a background in electronics. They have next to zero software development background. So what we did when I started teaching is that I started to experiment with the tools that were available on the market. And then I realized there were a number of shortcomings, like every designers mostly like to use Macs. Mac haven't had serial ports for ages. They all had USB ports. And still, there are professional hardware development tools that are released now in 2013. They still only have serial ports, which it's really weird because I haven't seen a serial port on a laptop for a long time. And on desktop, sometimes they don't even have them anymore. So we had to make something that would run on a Mac, that would be easier to use, that would be cheaper than what was available on the market back then, which, and also we had this programming language we sort of inherited from the MIT called processing, which was used to teach about programming to artists and designers. So we thought, well, why don't we try to make that run on a microcontroller? So that was based on Java. Microcontrollers tend to, they don't like Java very much. They prefer languages. It's easier to work with languages like C++ or C. So we did some experiments. Then one student of mine did a thesis on so different projects sort of followed. And then we ended up with the first version of Arduino, which, based on the work that this student Hernando Barragan did on a project called Wiring, we re-implemented it from scratch. So we reused the APIs, but we rewrote the whole thing to be completely open source, because we also wanted something that would be easy for people to reproduce, to build upon. So we wanted to remove the barriers. And one of the things that we did is also that, since at the time we haven't got, in a way, a clue how we were going to manufacture, we didn't want to set up like a classic manufacturing company or go to a venture capitalist or something, because obviously there was, back then nobody would have even talked to us. So we thought, let's release the hardware as open source so that people can build it if they want to. And we just started to make the PCBs of the sort of true hole version, and sort of we would just give them away to people as a gift. So just take this PCB, assemble one, and some people started to assemble it. So they went on the website, got the instructions, they started to write, to download the code, solder the boards. And so we got some feedback, and we started to build up a little bit of an audience, and that's how we started.
So talk a little bit about the transition from people coming into the 4-week class and spending the first 3 days soldering to the sort of scaled up manufacture. What happened? How did you get pushed? What triggered the...
We started to do introductory workshops for people outside of the school. I originally started this project with a friend of mine called David Quartielles, who teaches in Sweden. And the two of us both had similar issues with our students. We wanted to, there was a bunch of input that we gathered, and so we started to make the first sort of true hole versions. Then we met an engineer that was living and working in Ivrea that had experience in manufacturing stuff. He was actually helping me a lot whenever the school wanted to manufacture something with electronics. I would ask this, Gianluca Martino is his name, I would ask Gianluca to help me do that. So I said, well, can we manufacture 200 of these pre-made that we can just, sell to people? And then me and David managed to convince both Ivrea and the school in Malmo to buy 50 each. So 100 were sold, and then said, let's see if we can sell the other 100. Who cares?
Like on a website or something?
Well, we started to actually sell them like this, like in this by hand, but sort of really like saying, okay, I'm going to run a workshop in this place. I need 20 boards, and we would just sell them to people at the moment. The platform was unknown. It was not really proven. We were at the beginning. Luckily, we did some public demonstrations of how you could do with this, and people understood. So some people in different communities started to put out the word that there was this Arduino thing that was very promising. So we got people, we organized a workshop at the end of 2005 in London, which was the first workshop where really we put an ad and people paid and came. I think there were a number of events that lined up that kind of fueled this kind of viral aspect. So obviously, first of all, we had a friend that was teaching this kind of topics in the US, in at NYU, in a school called ITP. And he had a much bigger number of students. He had something like 120 students. And so we met him one summer in Italy doing a workshop, a project together, and we showed him Arduino. He started to play with it. He thought, okay, I like this. We can go somewhere with this thing. So he brought back a few prototypes. We shipped him a few more boards. And he started to use it with some of the second-year students. And then at some point in 2006, I think the platform started to work properly. You could do good projects with it. And so the first-year students, they saw what the second-year students were doing, and they said, well, we want that Arduino ourselves. So I would say that kind of gave us 120 power users, people who make beautiful projects. And designers have this feature that they tend to take their projects and document them very nicely, put them online, because it's their portfolio. Well, with Arduino, the idea is that you download a file, you plug the board. Okay, back in the days, you had to install a few drivers, but then, in the space of an hour or something, you were working.
You got a blinking LED?
Yeah, the blinking LED is the hello world. The blinking LED is the hello world of physical computing. So yeah, I think this viral aspect also coupled with the fact that we asked SparkFun Electronics, the online store, was again beginning to become very successful. So we asked Nathan to carry Arduino, and he sort of graciously accepted to do that. And so he kind of fueled our growth in the US. Then me and David Quartielles spent a number of years traveling around the world, but mostly in Europe at the beginning, doing workshops with, sometimes for free, just going somewhere and, sleeping in a
couch,
whatever we could sleep, yeah, and then run workshops. And that obviously kind of fueled that kind of aspect. But then it was a lot of people making projects, documenting them, putting them online, and then sharing information about how they built the product.
Where do you think this thing is going to go, and what are some of your dreams of how it could sort of change our world in a lot of good ways?
Well, in a way, I think there's a wider discussion about empowering people to be creative with technology. So because obviously nowadays the world that surrounds us is made a lot of digital technology. And there is a trend that I'm not particularly happy with, where people just buy devices and they just use the devices, but they are not aware of how you program, how you design, you build things with the device. So, for me, the iPad sometimes is the TV set of the 21st century. Obviously at home I have an iPad and I use it as a TV, because you're browsing the web, you're watching TV, you're maybe listening to music. Yeah, you can create with the iPad with certain applications, but it's not something that kind of makes you want to program the device to do more. And I think it's important, especially for kids, for them to understand that the world we live in, especially if you look at this room, this is a building that was designed by human beings, built by human beings. Every single bit was designed and built by a human being. So clearly, if you know how to design and build things, you can affect the world that surrounds you. If you are not able to participate in this, in the world of creation, in the digital space, you're left out. Somebody else is going to design your world. At some point, if there's no innovation, if there's no sort of renovation in a way inside the marketplace, then one company decides that that's the way you do a certain thing, and that becomes the only answer to a certain question, and nobody starts to debate that. Or, in a way, I think it's important to be masters of the technology.